Okay, hello students. So in this video we will learn how to determine the maximum and minimum point using second derivative test. Okay, so assuming that y equals to fx has a critical point at x equals to x naught, so we have three conditions. Okay, the first one, if your f double prime x less than 0 means you have a negative value, then the graph is concave. Okay, and fx has a maximum point. Okay, concave means your graph facing downward. Second condition, if f double prime x greater than 0 means you have a positive value, then the graph is convex. Okay, and fx has a minimum point. So obviously if you have a minimum point, your graph should be like this one. Okay, and lastly, if your f double prime is equal to 0 or does not exist, then the second derivative test fails. Okay, so if you face this kind of condition, means you have to use first derivative to determine the property of the extreme points. It may be minimum, maximum, or neither. Okay, let's look into this example. It is the same example as in the first derivative test. Okay, however, we are going to solve this one using second derivative test right now. Okay, let's look into example 2a, in which we have fx equals to x squared minus 4x minus 1. Okay, first of all, again, we have to find the critical point. Okay, so we have did this before, so if you don't remember, you have to go back to the first derivative test video. Okay, so I won't do it all over again. I just go straight to the point, the critical point, which is 2, -5. Okay, so how to test this critical point using second derivative test? Second derivative test means we have to differentiate again our fx. Okay, the f prime x should be 2x minus 4, so our f prime x will be 2. So obviously there's no variable x here. Okay, to for us to substitute the value of 2, therefore it is strictly f prime x equals to 2, which is greater than 0. So the test tells us if you have f prime x greater than 0, then you will have what? Minimum. So we have a minimum at 2, -5. That's it. Okay, you just refer to the second derivative test. Okay, so next example, example 2b, we have fx equals to the absolute function of x. Okay, so again, we have find this critical point in our previous video, which is we have critical point 0, 0. Okay, so now we are going to use second derivative test to test this critical point, either it is maximum, minimum, or neither. Okay, so using second derivative test, we have f prime x as 1 and -1 if your x greater than 0 and x less than 0. Then your f double prime will be 0 and 0, either x equals to greater than 0 or x less than 0. So what this value tells us, okay, if you still remember, using second derivative test, if you have your f double prime equals to 0, then it indicates your test fails. Okay, so when your test fails, don't worry. Okay, it is not that the function invalid. Okay, you just have to refer back to first derivative test. So if you still remember, okay, in our previous video, the using first derivative test, then we have a minimum and 0, 0. Okay, next example, example 2c. We have a function of fx equals to x to the power of 3 minus 2x squared plus x. Okay, so first we find the first derivative. We will have 3x to the power of 2 minus 4x plus 1. So again we have find this critical point. Okay, please refer to the first derivative test video. So we have 1 0 and 1 over 3 4 over 27. Okay, let's use second derivative test to test for the critical point, either it is maximum, minimum, or neither. So f double prime x will be 6x minus 4. Okay, differentiate again the f prime to get the f double prime. Okay, so we test the our first critical point, which is 1 0. So x is equals to 1. So we'll have 6 1 minus 4, which is 2. And then 2 is greater than 0. Okay, so when your f double prime greater than 0, obviously we will have a minimum at 1 0. And then our second critical point is 1 over 3 and 4 over 27. So when your x equals to 1 over 3, I will have 6 1 over times 1 over 3 minus 4, which is negative 2. So negative 2 is less than 0. So via second derivative test, this is a maximum. So we have a maximum at 1 over 3 4 over 27. Okay, next example, example 3. This example requires us to do both tests, the first derivative test and the second derivative test. Okay, so given y equals to x to the power of 3 plus 7x squared minus 5x plus 2, find all the critical points of the curve and determine the nature using first derivative test and second derivative test. Okay, so from the curve, it's the question already give you the curve actually. Okay, so from the curve we can see that we have two critical points, one here which is the maximum point and the other one here which is the minimum point. So this example is actually the one exercise I asked you to do in the first derivative test. Have you do it? Okay, so if you haven't do it, don't worry, let us do it together. So you have here y equals to x to the power of 3 plus 7x squared minus 5x plus 2. So before anything, let us find the critical point. Equate this equation, the y prime equals to 0. Okay, you can use your calculator to find the root of x. I have here x equals to 1 over 3 and x equals to negative 5. Okay, so this is the value of x only, so you have to find the value of y. If x equals to 1 over 3, then y will be equals to I have here 31 over 27, or it is 1.148. Okay, then if my x equals to negative 5, I will have y equals to, okay, you can do it together with me. This one will be equals to 77. Okay, so you have two critical points as in the graph. The first critical point is 1 over 3, 31 over 27, and then the second critical point is negative 5 and 77. Okay, now we will test using first derivative test and second derivative test. Okay, so let's use first derivative test first. So this is f prime x. Okay, you have x equals to negative 5, and then you have x equals to 1 over 3. Okay, so we will find a point before x equals to negative 5, in between the x equals to negative 5 and x equals to 1 over 3, and after x equals to 1 over 3. So you can choose any point actually, it's up to you. Let's say I choose x equals to negative 6 here, x equals to 0 here, it's easier, and then x equals to 1 here, it's easy. Okay, So this is the critical point, this is also the critical point. Okay, so we look into the pattern of the other points. If my x equals to -6, then my f prime -6 will be sorry, you don't have to use f here because the question used y, so we will continue using y. Okay, so y prime -6 will be 3 -6 squared plus 14 -6 minus 5, which is 19. So 19 is a positive value, so your slope will be increasing. If my x equals to 0, then I will have 3 0 squared plus 14 0 minus 5, which is obviously minus 5, and then minus 5 is negative, so the slope will be decreasing. Lastly, if my y prime equals to 1, I will have 3 1 squared plus 14 1 minus 5, which is equals to 12. Then 12 is again positive, so it will be increasing. Okay, so the pattern of the increasing and then decreasing and then increase again makes the critical point of x equals to -5 here as a maximum, and the critical point x equals to 1/3 here as minimum. Okay, let's use second derivative test. Okay, you must get the same answer using either test. Okay, so second derivative test means we differentiate again the y prime to get y double prime. So I will have 6x plus 14. Okay, so I test my first critical point, which is -5. I will have 6 -5 plus 14, which is -16, and -16 is less than 0. So if you have less than 0, it is maximum. So I have maximum at -577. Okay, and then my second critical point is 1/3. I will have 16, which is greater than 0. So if my y double prime or my second derivative greater than 0, means I have a minimum point. Minimum at 1/3, 31/27. So obviously you have the same answer using first derivative test or second derivative test. Okay, your critical point of -5 is maximum, while your critical point of x equals to 1/3 is a minimum. Okay, so from here you can see the difference using first derivative test and second derivative test. Okay, using first derivative test, you are required to test for the point before and after the critical point. However, using second derivative test, you are required to test for the critical point itself. Okay, so it's easier using second derivative test. However, sometimes the second derivative test fails. Okay, let's solve for the example 4. Okay, first of all, we have to find the critical point. So we have 6x squared minus 6x minus 36. This equals to 0. Then, just using your calculator, you will have x equals to 3 and x equals to -2. Okay, so we find the value of y. When I have x equals to 3, then my y will be equals to 3 to the power of 3 minus 3. Okay, you can do this together with me, okay? And then when your y is equals to -2, we'll have okay, so you have two critical points here. Okay, the first one is 3 -67, and then the second one is -2 58. Okay, so if you look into the question, okay, the question doesn't ask you to use either first derivative test or second derivative test, so you may use whichever test that suits you, that you think it's easier for you. Okay, so since we are in the second derivative test topic, I will use second derivative test to solve for the critical point, okay, to determine the critical point. So differentiate again, my y, I will have 12x minus 6. Okay, so I will just test my critical point. I don't have to find a point before and after the critical point, just test my critical point. I will have 12 times 3 minus 6, which is 30. Okay, then 30 is greater than 0. Obviously we will have a minimum at 3 negative 67. How about the second one? So y double prime negative 2 is 12 times negative 2 minus 6, which is negative 30. So negative value means less than 0. So again, if you have a y double prime less than 0, then you have a maximum at that particular critical point, which is negative 2, 58. Okay, let's solve example 5. So we have here y equals to x to the power 4 plus 2. So we have to find the critical point. First derivative is 4x to the power of 3. Then we equate this first derivative equals to 0. We will have x equals to 0. When x equals to 0, then our y will be 0 to the power 4 plus 2, which is 2. So our critical point is 0, 2. Okay, so again the question doesn't ask you to use either first derivative or second derivative test, so let's use just second derivative because it is easier. So second derivative test, differentiate again the y prime. I will have 12x to the power of 2. Okay, so we test our critical point, then I will have x times 0 to the power of 2, which is 0. This indicates that our test fails. So we have to use the first derivative test. Remember, when your second derivative test fails, use first derivative test. Okay, so using first derivative test, my critical point is x equals to 0. So I will have to find a point before and after the critical point. Let's say I choose x equals to negative 1 here and x equals to 1 here. Okay, so my y prime x is here. Okay, when your x equals to negative 1, y prime negative 1 will be 4 negative 1 to the power of 3, which is negative 4. So negative value means our slope will be decreasing. When my y prime equals to 1, then I will have 4, 1 to the power of 3, which is 4. It is positive, then it is increasing. Okay, so obviously the pattern of decreasing and then increasing means we will have a minimum. Okay, let's go into example 7. Given y equals to x to the power of 3 over 3 minus x to the power of 2 over 2 minus 2x plus 5, find if exists the inflection point, maximum and minimum points using first derivative test and second derivative test. Okay, so we haven't learned about inflection points, so I will skip that for now. We just go to maximum and minimum point. Okay, in next video I will show you how to find the inflection point. Okay, let's solve for example 7. This one's supposed to be example 6 actually. Okay, never mind. Okay, find y double prime, y prime. So I will have 1 over 3 . Then equate this equals to 0. Using your calculator, you will have x equals to 2 and x equals to -1. So again, if x equals to 2, your y2 will be 5/3. Okay, you can calculate it by yourself. Okay, if x equals to -1, then your y -1 will be 37/6. Okay, so please try for these two, calculate it yourself. Therefore, my critical point is 2 5/3 and -1 37/6. Okay, so the question asks you to use both tests, the second derivative test and the first derivative test. Okay, so let us use a second derivative test first because this is easier. Okay, so differentiate twice, we will have 2x minus 1. Okay, so test for our critical point. So y double prime 2 will be 2 times 2 minus 1, which is 3. Obviously 3 is greater than 0, then I will have minimum at 2 5/3. And then y double prime -1 will be 2 times -1 minus 1, which is -3, less than 0, so we'll have maximum at -1 37/6. Now let's use first derivative test. Remember, you will have the same answer using first derivative test. Okay, so first of all, I have x equals to -1 and x equals to 2. Let's say this is x equals to -1. And then this is x equals to 2, which is our critical point. Okay, so we choose a point, any point, before and after our critical point. So let's say here I choose x equals to 0, here I choose x equals to 3, and here I choose x equals to -2. So this is y prime x. Okay, we have to look into the patterns of each point before and after the critical point. Okay, y prime -2. So remember, this is your y prime, so you have to use this function, okay, to substitute the value. Okay, so -2 squared minus -2 minus 2, then I will have 4. 4 obviously is positive, then my slope is increasing. Y prime 0, I will have 0 squared minus 0 minus 2, which is -2. So negative here is decreasing. Y prime 3, then I will have 3 to the power of 2 minus 3 minus 2, which is again I will have 4, and it is positive, so it is increasing. Okay, so we have increasing, decrease, and then increase again. So the critical point of x equals to -1 here is a maximum. Okay, looking at the pattern. And then the critical point x equals to 2 here is a minimum, looking at the pattern. So we have the same answer as our second derivative test. Okay students, that's it for the second derivative test. Next video I will show you on how to find the point of inflection. Okay, till then, please do all the exercises, tutorials regarding first derivative test and second derivative test. Thank you.